Before we start with definite integrals, let's do a simple exercise on understanding what does definite integrals mean and the properties of definite integrals. Okay, so by definition in your O-level syllabus, right, that when we want to integrate an fx from 0 to 2, okay, this is called 0 to 2, the lower limit is 0, the upper limit is 2, equals to 4. So this is something like this, you know, what this is the graph y equals to fx, and from x equals to 0 and x equals to 2, this is the area that is under the curve, okay, that will give you 4 units square. Okay, so this is by definition, when we integrate a certain function from one x value to another, we are looking for the area under the curve from 0 to 2. Okay, so this is 4, and if let's say from 2 to 3 it is 10, so probably the area gets bigger. 2 to 3, then the area here is going to be 10 square units. Okay, now what happens if the area is under the axis, something that is going to be like this. Let's say this is y equals to gx, and you know that, hey, this is from 0 to 2. Okay, 0 to 2 is under the axis. That's why you can see over here, if I integrate from 0 to 2, when it's under the axis, it will give me a negative value. Okay, but that's not the most important thing right now. Right now is let's understand some properties of definite integrals that we are going to use. You are given these 4 values over here, or rather these 4 expressions over here. The integral from 0 to 2, the integral from 2 to 3 for fx, the integral from 0 to 2 for gx, and 3 to 2 instead. Okay, so in part 1, when we integrate from 3 to 2, now you see that the lower limit is greater than the upper limit. It is always good to change it such that the upper limit is greater than the lower limit. But in this case, you can't just change it this way, because it's kind of like vectors where the direction matters, you see. So we have to, when we change the order of the limit, sorry, this is 3, there must be a negative sign in front, okay, dx. And that's where we put it in. This will be negative, the integral from 2 to 3, 10. So when you change the lower limit and the upper limit, right, there is going to be a difference in sign because of like directions. Okay, and the next one, the other one would be, now if I want to, the integral from 0 to 3 fx, it's a little bit of like the MRT analogy I always give to students. It means I want the area from 0 to 2 plus the area from 2 to 3 fx. Now, it's important that in this part, right, the upper limit of the first one and the lower limit of the second one must be the same, such that they like meet. Okay, you want to go from Jurong East, let's say, to Dhoby Ghaut. You need to go to City Hall first, and at City Hall you cross the platform to change to Dhoby Ghaut. Okay, then we can just input the values that we have. This is 4 plus 2, integral from 2 to 3 is going to be 10 is equals to 14. Okay, so these are just some basic definite integrals that you have to know. And maybe I talk about part 4. Part 4 is asking for the integral from 0 to 3, 2 of fx minus gx. Okay, now in integration, we can always split the integral like that, as long as it's a plus and minus. For times and divide, you can't split, yeah? Okay, so you can split it up into these 2 expressions. Next is the 2 can put on the outside of the integral. You can put constants outside of the integral, minus the integral from 0 to 3 gx dx. And that will be 2, and then I think we got 14 over here for 0 to 3. Now I want 0 to 3 of gx. I have to be very careful. That would mean from 0 to 2 gx dx plus the integral from 2 to 3 gx dx. Let me just put everything in, minus 0 to 2. So let's look at it. 0 to 2 is simple. That will be negative 3 plus, hey, this gives me 3 to 2 instead. So if I want 2 to 3, I am changing the limits. Then I got to put a negative in front of the 1, and then I can work out the solution. Okay, so the important part of this exercise is that you understand that definite integral is actually looking for the area under the curve. If the area under the curve is under the axis, then you are going to get a negative value. You can always split the integral when it is a plus and minus, as well as multiples. We can always take out from the integral. So this is the first part. Understand this first part first before we go on to the second part.